Okay, so let's discuss Earth station parameters. So, Earth station is basically a satellite transponder na nasa Earth surface, no? So, itong device na to is responsible, no, para magbato ng signal sa satellite na nasa orbit, no, nasa outer space, no? So, kaya siya tinawag na Earth station. It's because nasa Earth surface yung transponder device natin, na? So, first parameter is the angle of elevation. So, angle of elevation is, i-designate natin siya as beta. Equal siya sa tangent to the negative 1 times 1 over tangent phi minus r over r plus h sine phi. So, yung mga r tsaka h, variables na r, h, tsaka yung phi, mamaya natin i-reveal, no? Kasi mayroong pang mga susunod na Earth station parameters na gagamitin din itong mga variables. No? So, let's proceed. Azimuth angle and the slant distance. So, the azimuth angle is cosine to the negative 1 ng negative tangent psi divided by tangent phi. And the slant distance is negative r sine beta plus square root of r plus h squared minus r squared cosine squared beta. Okay, so ito yung figure natin na i-illustrate kung alin ba dyan yung slant distance and yung azimuth angle natin. Okay? So, ito yung mga variables natin. Na? So, yung angle of elevation, of course, in degrees yan. No? Depende naman sa problem kung sasabihin na radians. No? But most of the cases, degrees yung gagamitin natin. Okay? And the phi variable is cosine to negative 1 times cosine psi times cosine lambda. So, yung psi natin is the latitude of the Earth station antenna. No? Binibigay naman sa problem yan. No? And yung lambda natin is the difference between the longitude of the Earth station antenna and the sub-satellite point. Okay? H is satellite height in kilometers. No? Hindi ko na na-edit to, pero kung makikita nyo dito sa baba, nilagay ko dito yung satellite height ng in a geo-orbit, no? In a geostationary orbit. So, ang default, pag wala kayong nakita sa problem na nagbinigay na height, no? And sinabi kung nasa geo-orbit yung satellite na yun, ang default natin na value is 36,000 km. Okay? Okay. Next, the Earth's radius, so yung R is 6,378 kilometers. I think constant din yan sa calculator nyo if I'm not mistaken. And the azimuth angle, always in degrees yan. No? Okay? So, let's have an example. No? Punta tayo sa kabilang software. Then, solve natin yung problem na yan. Okay. So, lakayan ko na konti ito. Okay. So, let's calculate the elevation angle, azimuth, and the slant range between the TVRO site, 38.8 latitude, and the 77 degrees to west longitude. So, ito yung Earth station natin, yung TVRO site. Yeah? And the huge galaxy satellite, ito naman yung satellite na nasa, I think nasa geo-orbit. Tama, nasa geostationary orbit. Sinabi kasi sa problem. No? At 134 degrees west longitude above the equator. Okay? So, I think, kunin muna natin yung, ano bang pinakamadali dito? Kunin muna natin yung mga, I think yung psi, no? Lagyan natin yung mga given. So, yung psi is the latitude. Binigay naman yung latitude na 38.8 degrees north. And, ano pa ba yung variable? Phi. So, yung phi natin is cosine to the negative 1 cosine psi 38.8 degrees times cosine lambda. Yung lambda natin ay difference ng dalawang longitude, no? Don't worry, kahit naman magkabaliktad dyan, still, cosine yung pinag-uusapan natin. Kasi, di ba, alam naman natin na mapa-negative yung nasa loob ng argument ng cosine or mapa-positive yung nasa loob ng cosine, still, ang sagot pa rin is positive. So, kahit pagbaliktarin nyo yan, no, either 134 degrees minus 77 or 77 minus 134, no? Still, pag nilagay nyo yan sa loob ng cosine, parehas pa din naman ang sagot. Okay, so, gawin na lang muna natin itong 134 minus 77. So, 134 minus 77 is 57 degrees. So, ang sagot natin dito ay cosine 57. Make sure naka degrees mode kayo. So, 64.88 or 64.9. 64.9 degrees. Okay? Next, beta is equals to tangent to the negative 1 over tangent phi, tangent 64.9 degrees, minus radius ng Earth natin is 6,378, so 6378 km divided by r plus h, 6378 km, plus yung geostationary height natin is 36,000 km, times cosine or sine 64.9 pala. No? Nalito na ako. Kasi puro cosine yung nasa phi kanina. So, sagot natin dito ay 6378 plus 36,000 divided by sine 64.9, and then 1 over tangent 64.9, so arc tangent, so 16.8 degrees. 16.8 degrees. So, ito yung angle of elevation natin. Okay? Next, azimuth angle naman. So, azimuth angle is equals to cosine to the negative 1 ng negative tangent psi. Yung latitude natin is 38.8. And then, tangent phi. Tangent phi natin ay 64.9 degrees. So, negative tangent 38.8, 64.9. So, 247.9. Tama ba ako? Okay, double check natin. So, psi is 64.9 negative. Double check natin. Negative tangent 38.8 divided by tangent 64.9. Okay. So, either 100, kasi medyo nalito ako dun kasi nakalagay kasi na tamang sagot ay 247, pero ang lumalabas ito ay 112 degrees. But anyways, I figure it out kung bakit ganun. No? Coterminal angles lang. No, yung 112 degrees is parehas lang ng 247.9 kasi I think ni-reference niya ata sa 360 degrees minus 112 degrees equals 247.9. Anyways, may decimal pa naman yun kaya mayroong 0.9. But anyways, either of the two parehas lang naman. No? Either 112 degrees or 247.9 degrees. Parehas lang naman yun. Okay? So, next, slant range. Slant range ay negative 6378 km sine 16.8 degrees plus square root ng 6378 km plus 36,000 km squared minus 6378 km squared cosine squared 16.8 degrees. Anyways, check natin. So, square root 6378 36,000. Yung kilometer ay gawin yung times 10 to the positive 3, no? Kasi naka SI unit tayo. Kaya lang kanina, kung makikita nyo dito, no? Itong nasa angle of elevation is in-stay ko lang as kilometers because naka-fraction siya. Makakancel lang din naman yung kilometer. Dito kasi wala namang fraction na magkakancel sa kilometer. So, kailangan yung i-gawing times 10 to the positive 3 para maging meter sila. So, minus 6378 meter squared cosine 16.8 squared. So, minus 6378 times into the positive 3 sine 16.8. So, ang sagot ay 40,105.2 kilometer. Or, ginawa ko na kasing kilometer, no? But anyways, ang sagot kasi dito ay 4105 to something. So, ginawa ko na lang kilometer. Kasi, naka-kilometer yung radius of Earth natin tsaka yung satellite height, no? And at the same time, parang hindi naman ata applicable na gawing meter kasi ang pinag-uusapan natin dito ay satellite, no? Parang hindi naman masyadong applicable kasi ang layo-layo tapos gagamitin natin meters. So, kilometer ang mas appropriate, no? So, okay. So, ganun lang, no? Masyadong madali lang kasi ano lang. Very tedious lang yung pagkuha ng mga variables natin tulad ng latitude, psi, tapos ilalagay nyo pa sa formula. No? Medyo tedious lang siyang gawin. Mahaba yung mga formula. Pero direct substitution lang. No? So, okay, let's proceed sa next Earth station parameter. So, next Earth station parameter is the orbital height. So, this is the average distance of the satellite above the Earth's surface. So, 21.64 orbital period raised to 2/3 divided by the Earth's or minus the Earth's radius. Okay? So, next is the orbital period. So, ito naman yung period that the satellite takes to rotate or revolve around the Earth. So, 2 pi square root of h plus r cubed divided by the gravitational constant times the radius squared. Okay? So, next, orbital velocity is the velocity of the satellite, no, that it takes to rotate around the Earth. So, 2 pi h plus r divided by the orbital period, no? So, let's have an example. So, determine the orbital period in hours and velocity of the satellite with a height of 15,000 km above the surface of the Earth. So, orbital period is t equals 2 pi square root of 15,000 times 10 to the positive 3 plus radius is 6378 times 10 to the positive 3 cube divided by 9.81 meter per second squared times the radius, which is 6378 times 10 to the positive 3 squared. So, equals to 2 pi square root of 15,000 exponent to 3 plus 6378 exponent to 3 cube divided by 9.81 times 6378 squared. So, ang sagot ay 31,809 or 89.336 seconds. So, dapat naka-hours. So, ita-times lang natin to ng 1 hour is to 3,600 seconds. Konting dimensional analysis lang. Divided by 3,600. So, sagot ay 8.635 or 8.64 hour. Okay? Next, the velocity. V equals 2 pi h plus r, so 15,000 times 10 to the positive 3 plus radius 6378 times 10 to the positive 3 divided by the orbital period in seconds. So, dapat naka-seconds. So, kunin natin itong 31,089. So, equals to 2 pi 15,000 plus 6378 31,089. So, that ay 4,320. 4,320 meter per second. Ay, so, madali lang, no?